and we have f of x, 2 to the x for x less than or equal to 1, 3 minus x for this, and the square root of x for this. Let me make sure I copied correctly. Yes, I did. Okay, perfect. Okay, so we are asked to graph this function and identify whether the function is continuous everywhere or not, or what's happening with it. What is the first thing I need to determine whenever I'm asked to graph a function? The very first thing, always, no matter what. Thank you very much. Thank you. So, if I torture you enough, you will always remember. Thank you. Perfect. Domain. Domain is the key. Obviously, I can change this into this interval. I can change this into this interval. And I can change this into this interval because I need the symbols. And it will also help me identify the domain. So, can anyone state the domain for us?
All real numbers.
Great job. Nothing is missing. Great job. The key values are definitely 0. 0 is always a key value, but 1 and 4. I will copy the appropriate symbols underneath. I will copy a bracket to the left, right under 1, and a parenthesis touching towards the right. 4, the same thing, right underneath 4, I copy this bracket, and here I copy the parenthesis. Yes, I know this is an overkill, but bear with me, because these may not be given to us in the correct order. So to the left of 1, I will be using 2 to the x. Between 1 and 4, I will be using the linear function. This is exponential with base 2. And this is a radical, the square root function. In each and every territory, without overlapping by any means, I plug in the numbers I see. So when I plug in 0, 2 to 0 is 1. When I plug in 1, I get 2. Right inside the bracket, and I know that 1 comma 2 will be a full point or an open point.
Will be full.
Excellent. When I plug in 1 on this side, you will be appalled, but you will let me be and plug it in, and I'll get 2. What does this mean? Is this function continuous at 1? I haven't even graphed it, but I can ask that question. Will this function be continuous at 1?
Yes.
Because the limit from the
Left.
will equal the, or equals the limit from the, and it equals the function value at 1. Excellent. So it will definitely be continuous at 1. I plug in 4, I get -1. I plug in 4, I get 2. Will this function be continuous at 4?
No.
No, the function will not be continuous. Not continuous. What type? Jump. That's good enough. I'm going to graph the function. Will the function be continuous from the left or from the right of 4, or none of the above?
Say that again, ask that question again.
Will the function be continuous from either side of 4?
No.
No, just the left.
Just the left, of course. Yes, because the limit from the left of 4 equals the function value at 4. So the limit as x approaches 4 from the left of f of x equals f of 4. So continuous from the left of 4. Good. So now let's graph it. 2 to the x is an increasing function on all its domain. So at 0 is 1, and at 1 is 2. And it is a full point. And this is the graph of 2 to the x. Stop right there. I'll use a different color just to make sure that you understand that they cannot overlap. Okay, now 1 comma 2 starts at the same point, and 4 comma negative 1 right here, and this is a full point, and this is a straight line, and it has to cross at 3. Maybe we should also put 3 in there because it's a very important point. It's an x-intercept. So this is the middle portion of the graph. Finally, 4 comma 2. Oh, I should have put in also 9 here. I need another point. So 4 comma 2, 1, 2, right here. It's an open point. And then 9 comma 3, somewhere here. So forgive me, I didn't plan ahead. So the only point at which this function is not continuous is 4. Continuity again, the limit from the left equals the limit from the right and equals the function value at that point. Okay, I'll stop here because we only have like 5 or 7 minutes